of the function f of x equals 4x cubed plus 14x squared plus 6x divided by x squared plus 8x plus 15. So I know that from my last example, if I want to find all the x and y intercepts of the function, I know that the x-intercepts, my y value will equal 0, and for my y-intercepts, my x values will equal 0. So I need to find all. So that means there might be more than one of each, or there might be only one. I don't know. It's just telling me to find all of the x and y-intercepts. So looking at this function, the first thing I want to do is actually simplify my numerator and denominator by factoring. So my numerator looks a little bit confusing and complicated, so I'm going to factor it off to the side over here. And then I'll put it back into my numerator later, but just to keep my work clean and neat and not so confusing. So I'm going to factor 4x cubed plus 14x squared plus 6x. So I can see here that the first factoring method I want to use is GCF, because I can see that 4x cubed, 14x squared, and 6x all have the greatest common factor of 2x. That means that this is going to factor into 2x squared plus 7x plus 3. Now looking at the structure of my new quadratic function, 2x squared plus 7x plus 3, I can see here that I can factor this again by using my grouping method. And I know that since a is equal to 2, if I can multiply a times c, so 2 times 3 is 6, I have two numbers that multiply to 6 and will add to 7. And those two numbers are going to be 6 and 1. So I'm going to split my 7 up. And I'm going to split that up into 6x and x. And now I'm going to group my terms, so the first two and the second two. So I'm going to have 2x. I'm going to have a bracket, since I'm going to have another set of parentheses. Inside my parentheses, we'll use a bracket for the outside. So I'm going to find the GCF between 2x squared and 6x, and that's going to be 2x, which will leave me with x plus 3. And then I know that when there's no GCF for my second pair, we pull out a 1. Because we know that 1 and 3 at least have a 1 in common. So we know that we can pull out the 1. And that will leave me with x plus 3. Close it with the bracket. So now I can see here that x plus 3 and x plus 3, they have it in common. So I'm going to take that as one of my factors. So we're going to have 2x on the outside and then x plus 3. And then the 2x and the 1 will be my other factor. So now I've factored my numerator, so now I can just rewrite this as f of x equals 2x times x plus 3 and 2x plus 1 over, and my denominator is much easier to factor. That's just going to factor into x plus 5 and x plus 3. Now that I've simplified this, I want to find any common factors in the numerator and denominator. So I'm looking for common factors. So here's my step 1. Step 2 is going to be my common factors. So I can see here that a common factor would be x plus 3 over x plus 3, so I can cancel those out. So now my simplified version of my function is going to be f of x equals 2x times 2x plus 1 over x plus 5. And now I can find the intercepts. So I'm going to split my page in half again to keep my work really neat. Going to do the y-intercept over here, the x-intercept over here. So once again, for y, my x is going to be 0, and for x, my y is going to be 0. So I'm going to use my function f of x equals 2x times 2x plus 1 over x plus 5. But I'm going to have 0 for x. So I'm going to do f of 0 equals 2 times 0 times 2 times 0 plus 1 over 0 plus 5. So if I simplify this, I know that 2 times 0 will be 0, plus 1. 2 times 0 will be 0. 0 times anything is going to be 0. So I'm going to have 0 in the numerator divided by whatever, it doesn't matter what's in the denominator. So I know that since my whole numerator is going to be 0 from when I multiply this 0 by this binomial, then I'm just going to have f of 0 equals 0. So my y-intercept here is going to be 0, 0. Now for my x-intercept, I'm going to use the same simplified function. So f of x equals 2x times 2x plus 1 over x plus 5. And since f of x takes the role of y, I'm going to replace f of x with my 0. So I'm going to have 0 equals, and then my function, I'm going to have 0 equals, and then I'm only going to use the unique values in my numerator. So I'm only going to use my numerator set equal to 0. So I'm only going to take this part of my function here. And now I can combine what I already know about quadratic functions or about factors. So when I have two factors being multiplied together, set equal to 0, I can set each factor equal to 0. So these are my unique values, or my unique factors. So I can take 2x equals 0, and 2x plus 1 equals 0. And I can get x equals 0 here, which means one of my x-intercepts will be 0, 0, which will definitely hold true, because since my y-intercept is at 0, 0, that means that my x-intercept will absolutely also, one of my x-intercepts will also have to be at 0, 0. Because if it touches the origin for y, then it'll also touch the origin for the x. So this definitely makes sense. And then over here, I'm going to use inverse operations. And I get negative 1/2, 0. So that is pretty much it. So I know that my y-intercept is 0, 0. My x-intercepts, I have 2. I have 0, 0, and negative 1/2, 0. So these are both x-intercepts. So just a quick reminder, just as something you might want to reference later. If the y-intercept is 0, 0, you should also get an x-intercept at 0, 0. So great job on the we do.